Hello everyone, I'm Francis here. Today I am going to dive into creating a smart contract, which is called Simple Bank Account. So I'm doing this exercise to complete the Questbook challenge for Quest 1. So just to show you the Quest 1 challenge is called Building a Bank with Solidity That Isn't a Toy. So this is a relatively simple challenge, and I will first of all go through the requirements of that challenge. Basically, to complete this quest, I need to create a bank account that allows a user to deposit money and withdraw money, and that is just to deposit and withdraw in ETH. We are going to extend this feature of the bank account to in Quest 2 and 3 to interact with other decentralized applications like Compound, and in Quest 3 we are going to extend the type of tokens that this bank account can receive and withdraw. So without further ado, I will now go through the code with you. So, first of all, the contract is called Simple Bank Account. And within this contract, I have, first of all, the get contract balance. This is a function to allow user to find out how much balance is there in this smart contract. The second function is called add balance. So this is the function that allows users to deposit amount into this smart contract. And you can see that, I create a mapping which maps the amount which map the user's address to the amount that they deposit. And with every deposit, this mapping will update the user balance, and msg.sender is the user who deposits money. Once the user deposits money, the balance will be updated, and the total contract balance will also be updated. And also, the timestamp, the time that the user deposits the amount will also be recorded. And once it's successful, it will return true. The next function is called get balance. This is basically the amount that user has deposited plus interest. Now, how the interest works is that we will calculate the time elapsed between when the user deposits the amount and when the user checks execute this function to check the amount available in the smart contract. So the calculation is basically that the principal plus the interest, and the interest is in this case 7%. So sorry, this should be 7%, no, 0.07. Sorry. So yeah, so you can see this is basically principal multiplied by 7. We can't do 7% in because we have to we can't use a floating number here. So we multiply by 7 and then divide by 100 here. Multiply by the time elapsed and divide by 365 days and 24 hours and 60 minutes and 60 seconds. So this is how the interest is calculated. The next function is the withdrawal function, where the user will be able to withdraw amounts from this simple bank account. So first of all, we define the address that will be this contract will be sending the amount to, it's called withdraw to, and this withdraw to address has to be payable. So this is so that the user is able to, the amount is able to be sent to the user. And then we will find out how much the user is able to withdraw through this amount to transfer. And one important thing to remember is that every time you want to, every time the user withdraw amount, the balance of the user has to be updated before the contract calls the user's call this transfer function to transfer the amount to the user. So this is a very important security feature, because if you don't update the balance first, you will end up be susceptible to re-entrancy attack with your smart contract function. So once you have, once the contract has successfully sent the amount to the user, it will return true. This is a Boolean, so it will return true if it's successful. If not, it will produce an error, transfer failed. So this is how you know that the transfer has succeeded. And the last function is something that I will explain later. So now let me, sorry, I also need to mention that we need to include this receive fallback function to allow this contract to receive amount. So now I am going to deploy this contract in Remix. So in order to deploy this contract, I'm going to deploy it to the Rinkeby network, because this is relatively fast. This is an Ethereum testnet. So I am going to do that now. Confirm. So I'm going to reject this because I clicked twice just now. And yeah, it's now deployed. So now I am going to show you how I can deposit amount to this smart contract. So by the way, you can see that this smart contract has an address. It's here. And if you want, you can go to Etherscan Rinkeby testnet and put in the address of your smart contract, and you will be able to see that appear here. And you see contract creation you have just created. I've just created a contract 36 seconds ago. And then now I am going to deposit amount into this smart contract. I will deposit 10 Fini. So 10 Fini, so 1,000 Fini is equal to 1 Ether. So 10 Fini is equal to 0.01 Ether. And then I click add balance. And then confirm. And then you will receive a notification once it's completed. Okay, it seems to have completed, right? Let's check whether we have the amount deposited. Okay, we can use this function to read the amount that I have deposited. And it gives you 10, it's basically 10 fini with 18 decimals. And you can see it's not exactly 10 fini, it's more than 10 fini because we have accrued some interest as calculated here. So yeah, we have successfully deposited money to this smart contract. Now, I would like to withdraw the money. And how should I withdraw? So this withdraw function will withdraw all the amount available to the user. You can't withdraw partially. In the next quest, I'm going to show you how we can code it such that you can withdraw partial amount. But in this exercise, I'm going to withdraw the full amount plus the interest. And you can see that it has failed. And why is that? Because we don't have the interest amount available in the smart contract itself. Because the smart contract can't generate interest out of thin air. Now, in the next quest, I am going to show you how we can get some interest from another decentralized application called Compound. So for now, we have to deposit some money, some ether into the contract so that we are able to withdraw. And this is where this add money to contract function comes in useful. So we are going to use this function to deposit to add money to the contract so that we are able to withdraw the full amount. Now, you might ask, if you deposit money through this function, would it not increase the balance that you have deposited? The answer is no, because if you deposit money through this function, it doesn't update the user balance. Do you notice that if I deposit money through this add balance function, the user balance will be updated through this mapping. Whereas if I deposit money through this add money to contract function, I do not update the balance. So if you check the user balance through by executing this function, it's still at 10 fini. It doesn't increase, right? Because the user balance is not updated. What it allows you to do is to be able to withdraw this balance together with the interest that you have earned. So now let me execute this function again. So now I can withdraw. Okay, it has done. So to make sure that we have indeed withdrawn the amount, let's check get balance. So it's 0 now. See? However, if you check get contract balance, we do have some money in the contract itself. That is basically the amount deposited through this function. Okay, so that's all for today. And thank you very much for watching. I am going to post the the full code at my GitHub down, and the link is down below. If you have any questions or comments, please post it in the comment section and I will reply. Thank you for watching. Thank you for your time. I'll see you soon. Bye.